All right, guys, are there any questions on the assignment so far? Any questions on any of the assignments so far, which is really just 6.1 and 6.2? Any questions on 6.1 or 6.2? What we're looking at today is a centroid. A centroid. Now, the centroid of a triangle is 2/3 of the distance from each vertex to the midpoint on the opposite side. So we're connecting the midpoint to the vertex. So the midpoint of each line to the vertex. Now, it does create several segments. Now, I consider them to be the big and small segment of the whole, because we have the whole length. So for this here, it would be, say, D to C. Now, the big segment is going to go from the centroid to the vertex. The small section is going to go from the side to the centroid. Now, for the whole length is going to be equal to, so 2/3 of the whole is equal to the big side length. So the bigger length from the vertex to the centroid is our big, which is 2/3 of the whole. Also, we could say that 1/3 of the whole length is equal to the small segment. So from the side to the centroid. Well, because if the bigger segments is 2/3 of the whole, the small has to be 1/3 because they're going to add together. Questions on this so far? Now, what's interesting is that the small segment is equal to half of the big segment. We can also say that the big is equal to twice the smaller segment. So really, if we have one of these three segments, we can find the rest. Any questions on any of this here? So if we look at the first example, I added two other lengths in, so we'll go on and find the rest. They tell us that SQ is equal to 8, and Q is the centroid. So we want to find QW, and we also want to find SW. Now, is QS the big length or the small? Big. Yeah, since we're going from centroid to the vertex, it is the bigger length, which means QW is the smaller. And we said the smaller is equal to half the bigger, or the bigger is twice the smaller. So we would take half of it and get 4. So QW is 4, yes? Now we need to find SW, the whole length, yes? There's different ways we can go about it. Well, we said the whole, 2/3 of the whole gives us the bigger, yes? And we can go through and plug the numbers in, but do we already have what the bigger length is? Do we have what the smaller length is? So the whole length would be? Because we could do it mathematically and say that 2/3 of SW is the bigger segment 8. And we could have multiplied both sides by 3/2. And we could have said 8 times 3 is 24, and 24 divided by 2 is 12. But really, if I have the big and small segment of the line, we do have the hole. Now, if we look at the other ones, let's go on and just fill the rest of this in. Well, we have RQ as 10, yes? RQ is the bigger segment, which means QV is which is? In RV, the whole length would be 15. Now we're told that QT is 12, so UQ would be, which makes UT 18. And that's it. Questions on this here? Let's look at the next one. In triangle RST, point Q is the centroid, and VQ is 5. So we want to find RQ and RV. And really with any of these here, if I have one part, might as well go on and find the other. It's a little bit easier to find that than the whole straight out. Now, VQ, is that the smaller, bigger, or whole segment? Side to the centroid is the smaller segment, which means RQ is the Yes, because big is equal to twice the smaller. So 2 times 5 is 10. So RQ is yes. And since we have the small and the big, we have the whole. We can add them together to get 15. Well, we can go on and fill out the rest of this. So SQ is 4. Because since QW is 2, QW is the smaller length. The bigger is twice the smaller. So we can multiply it by 2 to get the bigger, which will tell us the whole length of SW is, so UQ would be 5. Because QT is the bigger length that goes from the centroid to the vertex, and UT would be 15. Questions on this here? Are you ready for the next one? If BD and CF are medians, so medians just means it's connecting the midpoint to the vertex. So that means that point that they intersect is a centroid. Even though we don't have 3, it's still a centroid. Point E is the centroid. CE is 17. What is EF? So it's 17 over 2, which is telling us EF is, you're good. So since E is the centroid, EC, which they gave us, is the bigger length. Smaller is equal to half the bigger, so we take half of 17 and get 8.5. Now I didn't ask for this, but what would FC be?
FC is
17 plus 8.5. 17 plus 8 is? Questions on this here? Are you ready for the next one? In triangle RST, RP and SQ are medians. Find RU if UP is 7.3. So what did they give us? The smaller, bigger, or whole? So they gave us the smaller, yes? And we want to find what? The? So big is what? Twice the smaller. So you can add it to yourself or multiply it by 2. So RU is 14. Now if we wanted to find RP, we could take the 7.3 and add to it 14.6, and RP is 21.9. Questions on this here? In this triangle, if EM is 2x plus 3, and MG is x plus 5, what is x?
So we're doing algebra, so 2x plus 3 equals x plus 5. Do algebra.
So these are all medians, yes? What did we say a median does? It connects the vertex to the middle. So it means
they're equal, right?
Mm-hmm.
So
solve for the value of x. We can minus 3 from both sides first. So 2x is equal to well, I don't think so. It just asks for what x is. If we wanted to, we could. Well, 5 plus 2 is 7. They're both 7. Any questions on this here? I think this is almost the last one, or is the last one.
yeah.
RU, SV, and TW are medians of the triangle. What is the measure of RW? So RW, if RV is 4x plus 3, WS is 5x minus 1, and VT is 2x plus 9. Well, we know V is a midpoint, yes, guys? So we know V is midpoint, so it's going to bisect that side in half. U is a midpoint, so it's going to bisect its side. And W is a midpoint, so it's going to bisect its side. Do we know that TS, TR, and SR are congruent to each other? Do we know the 3 sides of the triangle are the same? No. But we do know that V, U, and W are midpoints. So we do have that 2x plus 9 is equal to 4x plus 3. And the value of x in all 3 spots where we do have it are going to be the same. So if we can solve for x, then we can plug it back in there. So the first thing we can do is?
So when we get x, we're going to put it back into 5x minus 1.
Mm-hmm.
We're subtracting.
Either way, which one do you want to do? So we minus 3 from both sides, which will tell us that 2x plus 6 is equal to,
4x.
then we can minus 2x, which will tell us that 6 is equal to 2x.
So we divide.
Divide by 2, telling us x is equal to, plug it back in to 5 times 3 minus 1 is 14. So the length of WS is 14, which, again, we were wanting to find what is RW. So RW is 14. The length of SR would be 28 if we wanted the whole line. Questions on any of this here? All right, let's look at the next slide. An altitude of a triangle is the perpendicular segment from the vertex to the opposite side, or the line that contains the opposite side. It's the height of the triangle. Now, with right triangles, it works out that it's actually one of the sides, is the altitude. Now, guys, up here. So an altitude perpendicular from the vertex. So if it's an acute triangle, most likely the vertex or the altitude is going to be inside the triangle. When we talk about an obtuse triangle, one of the altitudes, or all three, are going to be outside the triangle. The height of it doesn't necessarily have to be inside the triangle. Now we also have one more called the orthocenter. The orthocenter is the line containing the altitudes. So the lines containing the altitudes of a triangle are concurrent. This point of concurrency is the orthocenter, or where they intersect. So if we take the three altitudes and draw them in, their point of intersection is the orthocenter. Now the weird thing with the orthocenter is that it can actually be outside the triangle, because with obtuse triangles, their altitudes are actually outside. So it's either outside or, orthocenter is going to be on the angle. Right triangle, on the right triangle, or, obtuse triangle, P is outside. So where they intersect is actually out here. Right triangle, it's on the triangle. For acute, it's inside. So it's different places. Unlike with incenter, circumcenter, orthocenter is a little bit different. But that's it with this here. So that's 3 through 14.